Hello coders, welcome back to the new video on operators and operator overloading. And in this video, we are going to talk about few new operators which are introduced in C++ and very important concept in object-oriented programming, that is operator overloading. So let us begin. So the operators that we are going to discuss in this video are scope resolution operator, then pointer to member declarator, then pointer to member operator, pointer to member operator in another form, and then delete and new operator, which are memory allocation and deallocation operator. Then we have endl as the line feed operator and set w as field width operator. So let us check these operators one by one. So scope resolution operator we have already seen in the previous video when we were talking about classes in depth. So that is something that we are not going to check in this video. So other operators we are going to see. So we'll start with pointer to member declarator. So pointer to member declarator is used in conjunction with scope resolution operator and then a star. So let us try to understand this operator with the help of one example. So I have created this class math and I have a integer variable of public scope, and then inside of main function I am creating another integer which is a pointer, and I am defining my scope to this class math, and then it is a pointer. So this is how the compiler is going to process this information. So this is a pointer variable for a class math. In a way, this becomes your pointer to member declarator. And then equal to, we have ampersand math colon a. So a is public member of class math. As you can check here, a is public member of class math. So we are just specifying the scope here again, and then using the ampersand, I'm saying that this pointer variable is pointing to variable a. So in a way, this is simply writing as int star pa is equal to address of a. Okay, if you just notice over, so this part is something that is being added in addition, okay, which is just explaining the scope, or it is just resolving the scope over here. So when you create the object m1 of type class math, then when I write m1 dot a equal to 1, so I'm just directly assigning the value. So this is called as direct access method. And then when I write cout, value of a is m1 dot a, it will just print 1. And then when I write m1 dot star pa, which is a pointer to member a, and I'm writing equal to 2, so it is just going to overwrite the value of a, which was 1, with 2. Okay, now let us try to break down this part. So we have written m1 dot star p a equal to 2. So this is nothing but m1 dot value at a, which is equal to 2. So this is not a standard notation, but this is something that I would recommend, a way to understand how the compiler is going to execute this statement. Okay, so we know that we just replace star with value, and the value where the pointer is pointing, that we are writing along with the ampersand. So we read it as m1 dot value at the address of variable a, which is equal to 2. So this statement is going to overwrite value of a, and once this is done, so we are just going to print value of a is m1 dot a. So here it will print 2 instead of 1. So output of this program is value of a is 1 and value of a is 2. Now the next operator is pointer to member operator. So this is used by dash and greater than followed by a star, or alternatively it can be also used as dot and star. Now let us try to understand it with the help of an example. So this is, I'm just extending the previous class. So class maths has this public variable a, and then I have a public member function named as add. So in this function I'm just printing this cout add and then parenthesis. Now when I'm going to create a member function outside of this class, I am just writing it in this fashion. So let me break down this statement for you. So this is your scope resolution, that whatever here is belongs to my class math, and it is nothing but a pointer to a member function. So that can be identified by this parenthesis, which are outside of this parenthesis. Okay, so this is nothing but a pointer pointing to a member function. Now when this pointer is created, we need to specify where it is pointing to. So I'm writing equal to @math colon colon. This is again specifying our scope, and then I'm writing add. So add is nothing but my public member function. So here I'm creating one member function pointer which is pointing to this particular member function. Now once this pointing is done, I am recreating the variable that we were used in the previous example. I am creating one pointer to member which is pointing to a public member of the class. And then inside of main function, I am creating m1 as the object of class math, and then one pointer to object with the help of star operator. So this is object pointer equal to new math. So this is, we are writing in line. Now to access the member function using your pointer to member function, we can use a dot operator, then a star, which tells compiler that it's a pointer, and then this pointer to member function. Now notice that we always write this whole statement inside of a parenthesis. So that is how we can write this separate parenthesis which denotes that it's a function. And doing the same, we can add parameters if required. So in case this add function has parameters and we have this uh, pointer to member function, then we can specify our parameter list over here. So this is how we can access the member function using the pointer. An alternate way is to write this arrow symbol, which is combination of dash and greater than sign. But notice that we are using pointer. So this can be used when we have a pointer on both the sides, or when we have pointer on at least the left hand side. So m1 is my object to pointer. So when I have to access data member of object to pointer, I can use this new operator, that is this operator. And what is going to happen over here is that using this, when you have a pointer to object on your left hand side, it is going to call the member of the class dynamically whenever it is required. So another statement is m1 dot star pa equal to 1. So this is how we are going to access the member data. So what we are writing over here is m1 dot value at the rate of a, because pa is pointing to a. So we are updating value of m1 dot a to 1 using the pointer variable. So here we are updating value of m1 dot a with the help of pointer variable, which is pointing to public member of class math, and it is being updated to 1. Now with the help of the pointer to object and the arrow, we are updating the same variable to 2. So we are updating the variable of object pointer pm1 to 2. Now on the next line, I am writing m1 dot star pa. This is nothing but value at the address of variable a. So it will print 1 for this particular part, and the next is pm1, which is my pointer object, and with the help of arrow operator I'm writing star PA. So this is still nothing but at the rate A. So value at the rate A, so which is 2 in case of M1. This part is going to print 2. Now to briefly again understand it in the memory how it is going to happen. So we have our class math which has a variable A and a function add. I'm just writing it as like this, that it is a function and has some memory address to it. So these are two part of your class math. So when an object is created, let's say M1, so M1 has a copy of A and it can directly access member function add. However, when we are doing these two statements, in the first one what is happening is that we are creating a pointer to member function. So what we are doing is we are creating p add as a pointer which is pointing to this function, and then another variable that we are creating or another pointer variable we are creating is pa which is pointing here. Now when we create this particular object math m1, so we can directly use it with the help of dot operator like m1 dot a, or we can write m1 dot star pa, which is a pointer, okay, and is pointing to address location of your variable a, or address location of member variable a. Similarly, your member functions can be called directly with m1 dot add, or because we have created a pointing, we can call it alternatively as m1 star p add, which is a pointer to member function, and alternately it is just going to call add function. And other way to do is using the arrow operator, but on the left hand side of the arrow there has to be a pointer to object. Okay, so star pm1 is pointer pointing to your class, and whenever a new operator is being used along with your class name, a dynamic object will be created. So using this star pm1, I can use the arrow operator and still access the public member and public member function. But for the important point to notice over here is that in order to use the arrow operator on the left hand side, it has to be a pointer to object. So using the arrow operator, you can write star pa and access the data member of the class math, and similarly you can use arrow operator again to call the data member function like this. So arrow operator, then your star p add, and then parenthesis. So notice again, in case your member function has parameters, those can be passed inside this parenthesis, and this is going to be the output. So every time the function is called, so add and add are printed. In a way, we were talking about two objects. So using individual pointer variables, we have specified values of variable a to 1 and 2, and that is how these values are printed over here 1 and 2 using this statement. The next two important operators are new and delete. So using new variable, you can create variables dynamically, and these variables are added to heap memory, and using delete you can delete those variables from the heap memory. So let us try to understand this again by one example. So this is our main function, and inside this main function we have created one integer pointer star x, and I'm writing x is equal to new int with the array size of 10. So when I'm writing x is equal to null, which is going to be not true in this case because we have created a pointer linkage over here, so this statement won't be true because x is not null here. So this statement will be skipped and we'll be going into else part, and in the else memory is allocated is the message that will be printed. Now once this is done, I'm writing delete x. So x will be deleted from the heap memory from this point. So x so notice that the dynamic variable of this integer array is created using variable using operator new over here, and similarly using delete operator it is deleted here. So output of this program is memory is allocated. Now let us understand few more points about new and delete. So new puts variables on heap memory, and delete removes variables from heap memory. When delete operation is performed, the pointer to object is not destroyed, but value or memory block pointed by the pointer is destroyed. Okay, so pointer itself doesn't get destroyed. The value or the pointer where it is pointing, that value is destroyed, and the memory block pointed by the pointer is destroyed. Okay, so just to understand this, let's say you have one pointer PA which is pointing to variable A. So whatever the memory is this A is using, okay, so when the delete operation is used, so this pointer is not deleted, but memory allocated to A is deleted, and the value that is being stored over here is deleted. So next point is non-pointer object or variables cannot be deleted. So let us take one example. So let's say you have variable int x. So you cannot use delete x on it because it's a variable, it's not a pointer variable. So when we try to delete normal variables using the delete operator, the compiler will give us the error. So here the error is error type int argument given to delete, and it is expecting a pointer here. Now the next point is pointer to local variable cannot be deleted. So let us try to understand that with this example. So int x is a normal variable, and then I'm creating one integer pointer which is pointing to this local variable. So that pointing I have created using this statement, and when I'm trying to delete this pointer, the compiler will give me one runtime error. Now why is that? So when we create this variables, so especially the x is the local variable that we have created in the program, and it is not a dynamically created variable. So this variable is added to the stack memory, and the variables which are into stack, those cannot be deleted even when you are using the pointers. Okay, so pointer to local variables cannot be deleted. So the members which are allocated dynamic memory can only be destroyed using delete operator. Okay, so that is very important point to remember. Now the next one is two manipulators. One is endl and setw. Both are used to format the data that we want to display on the output screen. It makes a life little easier for us. So endl is nothing but a line feed operator, and it just takes cursor to the next line. So suppose this is your output screen and you are printing A, B, C, and then you have one endl operator. So from this particular cursor position, the cursor will move on to the next line. Okay, so this is your output screen, and this is your first line, and this is your second line. So because you have endl at this location, cursor will move on to the next line. Now in case of setw, it sets a common width or forces compiler to set a common width, so that a specified width of screen gets allocated to your variable to get printed or your message to get printed. Now let us assume that your screen width is, let's say, of 5 character width. Then in case you just have two character width, let's say you are going to print x and y, so that x and y will be get right justified, so it will be aligned towards right. Okay, now this is really useful when you are going to display some tabular form of data. So using the setw, that will really make your life easy. In order to use setw, you'll require to use header file. You'll be required to use header file IO manip, that is input output manipulators. Now let us try to understand this again by one example. So we have two variables A and B. I'm initializing both variables to 100 and 200 respectively. Then we have one cout statement where I'm writing set w4 and then I'm passing value of A. Okay, so in the screen what is going to happen is, let's say this is our output screen. Okay, so it is going to specify 4 character widths and it is going to write 100. So 100 will be written like this. Okay, and then we are writing set w4 and then I'm passing value of b. So again 4 character widths will be specified like this and 200 will be printed over here. Your cursor will be at this location, and because of this endl, the cursor will move on to the next line. And on the next line what we are doing is we are specifying character width as 5. So 1 2 3 4 5, so 100 will be printed over here because we are specifying value of a in the cout statement. Similarly, then set width 5 will create additional character width. So these are my 5 spaces. So again 200 will be printed over here, and because of this endl, cursor will move on to the next line. Similarly, the set of 6 will be specified on the next line and A and B will be printed. So output of this program is like this. So effectively your screen width has been started like this. So this was 4, then this was 5, so this was 5. Okay, so these are 2 character spaces, and then 3 because we had 6 as the character width over here. So 1 2 3, then 4 5 6. Similarly 1 2 3 4 5 6. So as I said earlier, set w is really useful when you have tabular information to be displayed. You have some tabular data, or in case of you have some banking application where you are required to display a balance sheet where the information will be displayed in tabular format. So using the set width and endl will really make the formatting easier. So that was all for the operators that we wanted to discuss in this video. Alright, so now we'll quickly start about operator overloading, very important concept in object-oriented programming. So operator overloading is nothing but ability to provide operators a special meaning. So in simple words, if you have, let's say, plus operator, which is addition operator, and what it does is it adds two variables. Let's say you have, let's say, two int variables, so it will add these two int variables and it will give you output as another int variables. Now in C++, this plus operator can have a new meaning, like you can add two objects using the plus operator. Okay, and it may give you something else, like it can give you the object again. So traditionally a plus operator will be performing its operations. So by default the plus operator is going to perform its default operation, but to a user defined data types, plus operator can still be used. Okay, alternate way to do it is using the standard member functions, but that is still a unnatural way of doing it. When we use plus operator, for us it becomes really easy to understand that I'm just adding these two objects. Okay, and it's more natural way of understanding. So it's a good advantage that we have in C++. Using operator overloading, we can write these type of statements. Another important point about operator overloading is that we cannot overload these operators. Okay, so dot star, scope resolution operator, size of, and conditional operators. So this is something that we cannot overload. Okay, for unary operators we can use operator overloading like this. So OP is my operator. You can either write it like this, so your operator and then your variable, or your variable and then your operator. In case of friend functions, okay, so assuming operator to be your function name, So OP is the operator name and X is the operand. So operand is what comes around the operator. So here this and this is the operand and this is the operator. Okay, similarly as we've seen in binary operator plus, so in binary operations your operands can be on either sides, your operators can be on the right hand side and left hand side, and then operator can be in the middle. Now when you have to access the same operator using the member function, you can use keyword operator and then the actual operator. So here X is your object and operator op, or let's say for this example let's say operator plus, that will become your member function, and this could be a parameter. Okay, now when you have a binary operator, then X and Y both should be the objects. Okay, so this particular line is for the example of binary operator, so this can be alternatively written as X plus Y. Okay, if OP is plus, of course. And again, when you have friend functions and you have let's say two operands or two variables, you can use it like this. So operator, then your operator, and then your two parameters. So let us try to understand how operator overloading can be done over unary operators. Okay, so again I'm taking example of class math. Then let us say we have three variables a, b and c, and using operator keyword and the operator plus, I'm overloading operator plus over here. Okay, so what I'm doing is I'm just increasing value of variable a and b. Similarly, I am overloading operator minus, where I'm decreasing the value of my variables a, b, c, which belongs to class math. And we have another function display. It is just going to print value of a and b. So inside of main function, what I'm doing is I'm creating one object m1 of class math, and then I'm writing m1.a equal to 10 and m1.b equal to 20. So a and b is initialized with 10 and 20. Now when I write plus m1, okay, so this is unary operator, and this operator is going to invoke this function. So this statement is equivalent to writing m1 dot operator plus. Okay, so these are my parentheses and then a semicolon. So these two statements are equivalent. So after execution of this statement, what is going to happen is value of variable a and b is going to be increased. So m1 dot a will be incremented to 11 and m1 dot b will be incremented to 12. So when I write m1 dot display, these variables will be printed with the value 11 and 12. And when minus m1 is executed, so this is equivalent to writing m1 dot operator minus and the parentheses. So what is going to happen over here is it is going to decrement value of a and b, so it will become again, so it will become 10 and 20 again. Okay, so again after writing m1 dot display, it will print value of a and b, which is 10 and 20. So here is the output of this program. So after execution of these two statements, value of a and b will be printed as 11 and 21. Oh sorry, I made a mistake over here. Instead of saying 11 and 21, I said it 11 and 12, so a small mistake. So after execution of these two statements, value of a will become 11 and 21, value of a and b will become 11 and 21, and after execution of these statements, value of a and b will be printed as 10 and 20. Thank you so much for watching this video, guys. Enjoy.